Okay, fantastic. All right, let's jump in. My name is Wojciech Galuba, and today I'll be talking about the AI research engineer role and how it is a combination of multiple disciplines in one. And I'll talk about this newly emerging role since a couple of years. A little bit about me. I have 12 years of engineering experience and leadership in building large-scale data systems, AI and ML applied in production, as well as AI research. Currently, I'm focusing on large language models and data-centric NLP at a large industrial AI lab. You can reach me on LinkedIn or Twitter. Disclaimer, this talk is solely just my own opinions and thoughts, and it's completely disconnected with any of my employers, and they don't endorse this talk in any way. Why I'm giving this talk? It's to shed light a little bit about what's happening behind the scenes in the AI world in large companies, demystify the role of AI research engineer you may heard about in the industry, and potentially I'm hoping to inspire some career change for some of you. So we'll go over the typical week in this role, then go over the AI research engineering skill sets, and then talk a little bit about what success means in this role, the growth, and what are the different career paths people take in that role. So this will be a 30-minute talk followed by the 15-minute Q&A at the end. So if you could hold your questions, the verbal questions, until the end, but otherwise feel free to drop them in the Q&A tab at the bottom, and we'll get to them at some point. So let's go through a typical week as an AI research engineer, and this is going to be made up examples, but they were very representative of what's happening in the companies worked at and also in the industry as a whole right now. So who is this mythical AI research engineer? So I went to MidJourney and asked for an image of AI research engineer. So let's demystify what this person does. But before we do that, let's a little bit go over the history of this role. So back in the early 2000s, the big data was growing. Google had its MapReduce. Yahoo had Hadoop, and Hive emerged, and Facebook has been using Hive and grew the data science team, and everything was about big data back then. Then over time, building on top of that stack, the advanced machine learning has been democratized in a sense. There are more frameworks like Spark, scikit-learn to give access to everyone to highly polished methods for ML that can be executed at scale. So at that time, the ML engineer role has grown as well in the industry, and over time, after a couple of years, we've hit this deep learning boom, this revolution since 2012 and 2011 events. And now in the industry, the deep learning, as you probably know, that it's hard to avoid AI hype in the news and everywhere else, and it's reached a certain level of maturity where experts in this field have an enormous impact in the companies. So I'll talk about the AI research engineer, and I put research in brackets because it's optional. You don't have to have research impact, but if you work in a company, you definitely have some business or production impact. So at a high level, the role is basically breaks down into these components. So it's about engineering. AI is a very engineering-heavy discipline, both in terms of computation, data management, and a lot of other aspects. that you have to glue all of those pieces together to make the AI successful in business. Then there's the research component that I talked about a second ago. Is basically everything's so moving ahead so quickly that you have to keep up to date, but also you have the opportunity to contribute new ideas, novel solutions, and run experiments of your own and contribute to the body of AI research yourself. So an external impact as an AI research engineer would be to publish research papers, code, and data sets. An internal impact will be apply AI in production to solve some business problems in an impactful way. So let's go through a hypothetical week of an AI research engineer. Sorry, I was just checking chat because I'm in a different window. So if there's something not going well, just let me know. Just unmute yourself because I'm not checking the chat as we go. All right. On Monday, we sit down. There's a roundtable of updates on the team. This happens on most teams, but what we typically do is search new experimental results, and then the whole team brainstorms what to do next, gives each other feedback. We share engineering challenges, blockers, data challenges. Very often, data is a very important component in this work. What can happen often is like some idea that we had a big bet on, some complex model that we had high hopes for fails for the nth time, and then we have to pivot. So this is a challenge that is somewhat unique because to the AI research work is the progress is very nonlinear. Very often you can always try something else to make this work, but at some point you have to make a decision to cut the losses short and move on. So this is one of the most difficult decisions that you will be making, whether to continue or try something else. And these decisions are made often as a team. So we combine intuitions of everyone what to do next. We continue improving the systems as we work on the research. So someone might share a cool hack that they found to save GPU memory or improve performance in this roundtable. So on Tuesday, there is a paper submission deadline to a major AI conference, and it's in 3 weeks. So the team that is involved in writing this paper sits down and meets to reassess where we are. Do we have enough results? Do we have a good story for the paper? And then we divide up the work and what to do next. Another thing that happens on Tuesday, we find that we are severely undersampled for the Southeast Asian set of images that we have in our data set that we use for a very important AI model. So bias in AI is a very important issue, so we try to brainstorm ways to improve the data diversity, and there's a bunch of ideas, and we decide to try them out. Tuesday is also an in-office day, so people go for lunch together. We also a research engineer might meet with their mentees. This is something I personally enjoy a lot, mentoring people, and mentoring is an important component, learning and also teaching in this role. Mentoring is always a two-way path. So if you're mentoring someone, you will learn something else. It's not always a one-way. Wednesday, we've been debugging this really obscure part of the system. We had a random stack trace that we didn't understand for 2 days. We thought it's something wrong with our model, but it turned out it's some case of distributed communication framework not really working well for us, some edge case that we hit with our specific use of that part of the library. So we're all disappointed that it took us so long to debug, but we fixed it. So this is an illustration of the fact that stacks are really deep and complex in AI, and very often the debugging skills, both on the AI side, but also on system side, are super valuable, especially if you're doing some large-scale distributed compute. On that day, the production team ran offline evaluations with our model. they had great results. So now we're starting to work on moving those models to production, which is often, not always, but often a separate process that requires different engineering skills and making systems fast and efficient at inference time at large scale. We also finished a big set of experiments, and we go into analysis mode. So data analytical skills are important. So on Thursday, we saw again a problem with data, low quality issues, data duplicated. So we fixed our data pipelines. Then there's lots of code review. So it's not only research, it's about code review as well. And then we have a long design chat about some new approach that we want to try out on the whiteboard, if it's in person, or just sketching it out on some app. And I started literature search into a new problem as I work on this. As I said, learning is super important, and basing yourself on the latest solution in AI, because it's moving so fast, it's also important. On Friday, big day. We publish our new open source framework we've been working on for a couple of months, and companion data sets, so people can use it to train their own models, but also use our framework to expand and build the models in their own special way. I finished one section of our paper on Friday and broke up with writing some automation and kicking off some experiments for the weekend. So that was the sampling of the different events that can happen to AI research engineer throughout the week. This was, I thought it was a good way to just illustrate what the role is like. And this is, again, subjective, but talking to my colleagues across the industry, it's something that's happening as well for them. Let's talk about the skill set now. So that is needed to succeed in this role. So let's start with the technical skills. So we'll walk over those. It might feel overwhelming at the beginning with the number of skills that you need to succeed in this role. But just to highlight, no one is an expert in all of these, but having a basic understanding of all of these is really helpful. Let's start with the foundational skills. So software engineering, obviously, right? That's one of your big components in this role is engineering. So you have to have those fundamentals. Both quick hacking, but also developing with mature software engineering practices like integration, unit testing, and proper testing at scale, especially when you do that in a distributed way. Then fundamentals of ML. So this goes without saying, like, ML, AI fundamentals are super important to be successful. We see people really struggling coming into this role without that background. And distributed systems, a lot of what we do is done at the scale of multiple nodes. So you need to have a basic understanding how to debug distributed code, the different frameworks that are available, and how to also go lower in the stack to understand and improve the different pieces of the system you're layered on top of. And then finally, responsible engineering. This is mostly about responsible AI. AI has an incredible impact and has transformed industries, but it carries a lot of risks. So biases in your data sets, not properly testing system before release, and AIs, especially when making many decisions per day, have to be verified extra. And in the other domains like medical domains, you need a very high level of scrutiny. So there's lots of different skills and background that come into this. It's not a well-established set of principles, but it's slowly emerging. The standard practices are slowly emerging. All right, so now we're walking over the top part of the skill sets tree, And we'll go real quickly over this. So one of the important parts of any successful AI project is the data source and data acquisition. So finding existing data that already exists for a given product or instrumenting the product, logging new data is important. Designing labeling pipelines, because sometimes when you use supervised learning, you need a lot of labels. So for example, marking where the cells are in a medical picture, or classifying images. And there are different tools for doing that. Amazon Mechanical Turk, Scale, there's lots of other things in the market out there. So designing those labeling pipelines is a skill set on its own. You can also find and use open data sets. For example, Hugging Face has lots of data sets that you can easily try through their API. Then there's data science engineering, data preparation for training, then analysis after you get the results of the training, and understanding the performance of your models. It's a super important skill. And also data pipeline engineering to make the pipelines rerunnable reproducible and also testable. And those are really important skills that make your work faster when working with AI, and more reliable. And this is a skill that's also important for understanding any anomalous issues with your data, which often leads to problems in your model. And then there's finally, not finally, but there's AI ML modeling, which is the core part of the work. So building AI models, very often borrowing from other research papers and training them, borrowing from the open source community. Again, there are many repositories of good models like Hugging Face and other places. And there are a few frameworks you can choose from. Many of them actually also support deployment in production to make it easy from go to research to production, like PyTorch. Then you train the models, plan your experiments, and really carefully plan this loop of experimenting, interpreting results, experiments again, branching out into different variants of your model and optimizing it over time. You will also iterate on the data as you go, because you might discover issues with your data and create more cleaned up versions of the data. And to mention, there's also AI specialization. So I've been talking AI as if this giant blanket term, but there are many sub skills there. So natural language processing, computer vision, automatic speech recognition, just audio processing in general. There are also different niches like working with graph data, recommender systems, reinforcement learning. And finally, the latest that you already saw a demo of in this presentation is multimodal, so text and image together or other modalities combined. So this is gaining popularity now because these models are really powerful when you combine modalities together. And then there's a slight division and specialty between perception, so just purely analyzing the input, like does this image contain a cat, and generation, so generating images, generating text. So with the recent success of generation of text, you've seen what this area is capable of. And then finally, there's the next step is the AI ML production. I said a little bit about this already, is forming good partnerships with the production teams, understanding the problems, identifying opportunities where you can apply AI. Once you develop the model, there's this whole art of transitioning models to production environment and measuring how they perform, monitoring them. So this is this whole space that is already mature in the machine learning world, and a lot of those practices carry over to deep learning. And it's termed as ML ops. Usually you may have heard about it. And then the research component, it's doing the science with AI and ML. So staying up to date with the bleeding edge research is super important, as I mentioned. Because the field moves so fast, a lot of that research is published with papers or soon after the papers go out, if the paper is offering is demonstrating some really good progress or on key metrics in a key domain, it's going to be very quickly implemented by the open source community and made accessible. So being able to tap into that is super important. And then the core part of the research is developing your own method and potentially publishing as well. And this is where the scientific communication is super important. Speaking of, so we talked about tech skills so far, but there are lots of soft skills that are important at your job on a daily basis. These are a few selected ones that I think are somewhat unique to the AI research engineer role. So communication, because you're operating in an environment where, as you saw, the set of skills that are required are so vast. Usually you have teams that are composed of experts in different areas. So in order to communicate with and work with others effectively, you have to communicate what your problem is and seek help. You also need to communicate well with the production teams about what your model is capable of and what they need. There's also scientific communication when you write papers or write presentations to present your ideas to others externally. It's also important. And then finally, communication around your own roadmap, your own intentions, what you want to work on, getting feedback on that in a complex area like this is very important. Another aspect is risk management. So I talked about this already, is very often the way you make progress in AI research or engineering in a system in this area is just like peeling an onion. You basically do a set of experiments, you make a set of hypotheses, you don't know whether they will be successful or not, and then you learn something new, and then you branch out and continue branching out. So at some point you have to decide to stop. You also need to be able to assess whether a big engineering investment in something you want to try out is going to pay off. So you have to make certain guesses and manage the risk of that investment. So that's very tricky in this role, and it takes time to learn. And next one is what I, for lack of a better term, call it tech adaptivity. So when you're doing software engineering on a product, there's usually a set of well accepted practices that people use, but people follow. And this is somewhat fixed throughout the project. There's like a certain practice around a product or a project or a team. In a research project, you very often adapt. If you need to do a quick analysis, you often hack a script together. If you have an early stage idea, you write it so it doesn't have to be reusable, doesn't have to plug into anything else. Then, as soon as you start noticing patterns in your code, or you have the intent on a longer project, you put that into a library or a framework where you apply more rigorous software engineering practices. You test it. You know that there's going to be a team working on it. There will be others reading the code. And then finally, if you go on to open source something, you want the quality bar to be even higher, because you know that you might attract a community and you want the community to be comfortable to contribute to your code. So you cover the whole spectrum of software engineering practices, and you have to adapt. And then effective learning and teaching, this is something I mentioned already, is mentoring others and learning from others, and figuring out a good method for you to stay up to date and learn continuously is super important, and leaning on others for that. All right, let's talk about a career briefly. This is the last section. So what success looks like in this role. So putting your AI work into production. It's super rewarding when you see a team come back to you, hey, this method really improved our metrics, and we increased revenue by X%, or engagement went up. Then publishing a research paper and getting citations recognition, this is something that's more rewarding to you, because you get this external visibility, you build your personal brand outside. The same with releasing something open source. Like, you put your name out there, and it's super rewarding when a community engages with what you built. You get the traction on your project, and Sometimes it's overwhelming when the project becomes popular. People post a lot of issues, a lot of changes, but that's a good type of overwhelming. Then finally, growing your scope. Of course, this is like true for any place. Is growing your scope in terms of the amount of projects, the amount of people that you interact with and mentor. Maybe you would be put in a leadership role of either people manager or just technically managing a set of projects. So some example growth paths, which are related to the success criteria, success examples that I mentioned. You may specialize to work with specific products or product team and know a lot about the product and know a lot about the opportunities in that product and have a lot of impact there, and you grow, you get promoted in that role because of those accomplishments. Then there is the science part. You can be a well-recognized researcher worldwide. You go to conferences, you publish, you start running multiple projects with multiple collaborators around the world, using the company resources to help you move forward. Then systems expert. So AI is very, very engineering heavy, and the stack is deep, and there are so many problems to be solved, and so many opportunities for optimization of any kind, opportunities for helping other people debug the problems. So you can definitely specialize in that. And especially when you get plugged into projects that require a lot of compute, like training large language models is a good example. And all the parts of the stack get challenged, pushed to the brink, and that's where all the systems problem pop up, and that's where you can grow. And data specialist is another one. Is data aspect is very often underestimated because like the modeling is the sexy part, but data is not something that people often appreciate as important. Like if you look at the GPT 4 paper and look at the section of people that were involved in data, it's the biggest. So this tells you the relative importance of the different pieces. And then finally, as I mentioned, you can grow as a tech or organizational leader and managing people, managing managers, and so on. So if you look at this skill set graph, it's super overwhelming. And in reality, nobody is an expert in all those areas. If these people are extremely rare. So unicorns don't exist. So what works best, and this is my personal opinion, is just playing into your strengths. What do you already know? What do you enjoy most already? Where is this feedback loop that you can create to build on your knowledge, be an expert in a given area, either data or modeling or data acquisition? How can you play into that and contribute to a larger team? So it's a little bit about starting the AI career. People come into this role from many different places, but the important part is to invest in strong foundations. So software engineering, AI, ML, data analysis and data processing, data wrangling, cleaning up. Those are important skills that will really help in a job. Another thing, there's so much stuff out there in open source, and so much energy in this area right now that learning by doing, learning from others is probably one of the best ways to get into this field. Going out, doing wiki projects, going to hackathons, and through the hackathons also connecting to the local community and other local events and interacting with folks on Twitter. Early in the career, getting into this role is through internships or some other programs like AI residence that's offered to PhD students in a bunch of places. And later in the career, it's looking around and maybe looking for opportunities to apply AI ML where you are now, or looking for budding early stage teams in your own company that are doing machine learning and teaming up with them to do something. And again, playing to your strengths. Like come into this with your strengths and say, okay, I want to learn the other things, but here's my strength. So thank you so much. That will be the end of the talk, and thank you for your attention. And let's see if people have any questions. Okay, so Ram asks, what is the typical workload of an AI research engineer compared to other dev engineer? So I worked in both roles. I worked as a more classical software engineer on the product team, and also worked in the AI research engineer. And if by workload you mean the number of hours you spend, it's comparable. It highly depends on the projects, the visibility of the projects internally within a company. Some projects are more intense than others. Probably depends on the company culture. Again, my experience is colored by one company. Multiple organizations do. So, but people want reasonable work-life balance. So you can maintain it in both roles. Does anyone have any other questions? So Francisco asks, would you say that the job title data scientist and ML engineer are outdated, or do they coexist with AI research engineer? That's a great question, Francisco. AI is just, to me, it's just a brand name. It's basically machine learning that uses deep learning methods and the modern deep learning stack. That said, there is also the input difference, because the deep learning has much bigger data requirements. And you also have more complex data types like videos and images. So there's a slight difference in skill sets, but ML engineers are absolutely not outdated, and data scientists and as well. There's so much value these people bring on a daily basis in any company, because there are a lot of areas in most companies where deep learning is simply not going to be impactful and will be a, excuse me, a big overkill. Especially in places where you work with any kinds of tabular data or simple feature data. All right. Ram asks, is it common to publish papers? That's another good question. It depends a lot on the mission of your organization. There are research organizations within bigger companies, so Google Brain, DeepMind, and Meta, and their research impact and advancing the state of the art in research is one of the important pieces. So publishing is something that people do. Even in slightly more applied orgs that have that work more directly with the product teams, and the primary goal is to deploy AI in production, they tend to also innovate, and they also want to have some external visibility. So they still find time to publish. But this is by no means a rule. Mansour asks, will we be getting a copy of this recording via email? I think a few days later, the Codementor will make this video available, and you may get a notification on email if you participated. I'm not 100% sure, but just check back to the same link that you used to join, and you should see the presentation. I will also make the slides available somehow. I'll figure it out with the Codementor people. So Luigi asks, where do you see the industry headed? It seems like we are heavily in the hype of AI right now. Will more companies that didn't consider AI start to incorporate it into their business? That's a good question. AI is definitely on an absolute peak of hype because of the recent events. I think those recent events also opened up a huge swaths of opportunity for startups or other companies, either to replicate what OpenAI did, or actually build on top. I feel like we're going to continue to see breakthroughs of similar magnitude over the next years. At the same time, I feel like we're going to see a lot more commoditization of AI as a tool, as a stack, just the same way as it happens to more basic machine learning algorithms. So companies like Databricks, for example, are doing that for many businesses by giving them a full stack of to work with to apply AI. All right. And in the other tab, there is Evgeny asks, oh, hold on. I missed all the questions you posted in chat. Do you use ChatGPT or Copilot in your daily work? Stefan asks. I do. I do use ChatGPT quite often, especially when I want to write a quick script that I don't want to invest time in, or when I'm learning something new. What do you love the most about the job? And the least, asks Olga. I like the biggest thing that I like about this is just the interdisciplinarity of it, and I'm constantly learning. Also, the field is moving really fast, and I like the intellectually stimulating environment of doing both research and engineering and solving problems on both ends. What I don't particularly like is this bet making. When you do research, you always make a bet, and it very often turns out to not work. So you have to constantly adapt, and failures are sometimes hard to accept. What are some not very technical job opportunities in the area of AI? Evgeny asks. Not very technical job opportunities. I think just applying AI, and one area is human-computer interaction. Using AI to design user interfaces. Designing user interfaces on top of AI applications is very tricky. Also, designing user interfaces for data acquisition, I mentioned labeling, is an area that is not super technical, but requires a lot of intuition about understanding what people use, how people use your user interfaces, and how to best optimize for specific use cases. That's most of it I can think of. That's a great question. I'll have to think about it more. Francisco asks, how important is having a PhD nowadays? It seems that early during the deep learning boom, you needed a PhD to transition from ML engineering data scientist to work on deep learning. PhD is not super important for the AI research engineer role. You can enter the role from a traditional software engineering background, but you do need the background in machine learning. That is really important, and you can demonstrate a background by, as I said, working on your own projects or being involved in machine learning projects in your own company. Just transition within your own company. There are many ways to do it. Let's see. Uh, 417 Tushal asks how I can improve my research in AI and ML. I think I partially answered a question. Is the best way to learn is by building. I repeat that all the time, but I feel like this is the best way. Challenge yourself. There are places like Kaggle where the challenges are available to you, so you just go there and can learn. Hack with others in hackathons, and read a lot. So just build those fundamentals as well. All right, maybe we have time for one more or two questions. We're coming up to the 45 already. Let's see if anyone is curious about something else. Oh, thank you. Thank you for coming, everyone. It's been a pleasure sharing with you what happens in the AI kitchen, and have a great weekend. Thank you so much.